Good day from before your eyes. Today we are looking at student score data, and essentially the structure of the data is consistent throughout. There is 60 students across by 9 subjects by 7 assignments. There are 2 versions of this data, student body group 1, student body group 2. We're going to be looking at both the actual data itself and the mean normalized version of this data and how it can be produced visually. As you can see, it's a fairly large data set, and looking at the data doesn't provide us answers. So I tried a different methodology and decided to ask ChatGPT to analyze the said data and produce us a report, which you can see very quickly here. It goes on to analyze the data, find its key criteria, and maximize. But here's what we're looking at. We're looking at there's the subject matter, and we're looking for the best performing students, worst performing students, and then you have to go and then analyze the actual student itself and try and achieve that visualization relative to its peers. In doing that, I've produced a number of visual frameworks, and I'll start at this simple level. Here we have the 60 students, as you can see in the top right hand corner, and we can view them relative to the performance. Each one has been set to a normalized criteria of comparison, and the color range essentially is above 85%, or in some cases 90%. It goes blue, and below 50% it would be of a different color, probably red, and then orange in the hue. There are 4 levels of this color segmentation. As you can see there's the blue, and the score there's 100% for that particular person, as opposed to the red where the score is 53. So the heat map is working essentially as an indicator of performance, and this donut type shape is essentially the 7, 1, 2, 3, 4, 5, 6, 7, the 7 assignments, and it's been seen by assignment level. This would be how it is seen in the totality of what the data actually is, and this would change accordingly through the data set. A different alternative view of this we've just seen would be to look at a slice of that data, as we've just done, and see if we can try to identify any trends within the data set. Looking at this data, one can observe the format of the rows, which is this one on the right at top, where there is a number of students that are clearly excelling as an overall factor, because the hue of the blue is greater than the hue color of the orange and the red, and therefore the student body is fairly well adapted to the course. We then can take it one stage further, which amounts to virtually the same thing, and we do an inner and outer chamber now. And the inner chamber is the average for that subject relative to the module. You can see here the student had 98% and here 96%, whereas the average student was at 86. So one can immediately get a visual on that. The same applies in this case to the data end line is essentially a uncharacterized value. And that's why you saw that glitch on the screen itself. We now can see this data. Won't be able to get behind this, it appears. So we will have to switch to a different screen. And now within this section here, we are looking at the same data. As you can see, we're looking at art. In this particular case, we drill down to that level. And we are looking at two frames. One would be the standard model, in other words, the median value or the norm, and the other would be the actual. And one would compare the two and get an interpretation through the concept of a fingerprint of how the students are performing in and over time, over the relative subject matters. We could look at that one stage further in totality once again. Apologies for the descriptions overlapping, but they will disappear as soon as we go to, let's try this time instead of art, let's try PE, because I know that certain students were absent. There's the clear absence of the students, and certain students clearly are performing in their efforts of physical exercise. We take this one stage further. We use that data and we normalize it. And we normalize it at a higher value. And from that, we are able to establish this comparative map, which again is by subject matter, as you can see. And the outward frame, the outer edge, the outer boundary, are essentially by the student in the subject matters, and we'll be able to obtain that information quite readily. And the inner chamber is the average once again. What you can see here is the outer performance on the higher level playing field of the actual student itself. I'm hoping that we have one further visualization of that, but once again it is hidden behind the screen here and we actually need it. Let me pull. Okay, now we have the dashboard, so to speak, view of this data. There are 9 subject matters around here, and each subject matter has its reference point. We're looking at student 30. Now we're going to go a little bit and go to the next student and the next student. And from that position, we are able to compare how the student is doing in the totality of the dashboard. There's 9 subjects, as you said, and these are the modules within them. So we could go down to a subject matter. Let's choose subject matter 9. And from that, we would see the relative value of the subject and how it performs. As you can see, there's always a mixture between the different hues of blue, red, and orange, and tan. That's indicating the values achieved by the student. Once again, we come back to the dashboard, and we get that clear representation this time of the achievement of the students and how atypical they are relative to other students in the said subjects. So we're looking by student at 9 subjects and the performance of those students relative to those 9 subjects per assignment. And that can be seen in comparison, lastly, to a structured versus unstructured data representation, which probably isn't the best way to end the conversation, but unstructured, it looks like, if I can get there, unable to get that file open, so I've gone back to the ChatGPT and visual analysis and interpretation, and one can compare what we've just observed in the visuals compared to this detailed analysis of trying to achieve the mean and the standard deviations, which are important. Here's the mean, the standard deviation. But what meaning does that give relative to the visualization? The answer essentially would be a combination of the visualization and the knowledge of the standard deviation and mean constructs and the performance tables of the different students. Here we can see top students and low students. But compare that for a moment to what you saw earlier on, whether it be this model or any one of the other models that make a meaningful impact visually as to the framework of the student. Thank you for watching Before Your Eyes. Hope to speak to you again soon.